Hi, Julian here from PopcornFX. In this video, I will show you how to use a texture to control where to spawn particles. And we'll also see how to use an animated sprite sheet to spawn the particles on an animated texture. We'll see two main ways to do that. The first one is called rejection sampling and is pretty much the usual technique you'd use in VFX systems to achieve that kind of effect. And the second one is what we call density sampling, and it's a pretty neat feature which allows you to have zero losses in particles, unlike rejection sampling where all the particles you spawn end up in the final effect, no matter the shape and density of your texture. So the first thing I'll show is the rejection sampling. So I'll start as usual with an empty effect, which I'll name spawn on texture. I will drop a multiplier node that I'll set to infinite and which will spawn 1000 particles per second. I hit Ctrl R to get it running, and I will create a layer where I'll add a billboard node with the simple dot texture. So since 2.8 you have a helper node which is called spawn on texture, which does most of the job for you. So you'll give it a texture and it will output position and colors and optionally the UV, and by default it generates a random UV and will sample that texture and, you know, depending on what you wire in the diffuse, it will output the proper color, etc. So here let's say I pick up like the PopcornFX logo. Now if I wire the color in there, I get the expected result with this texture. So I'll bring down the size a bit and I'll increase the spawn count to, let's say, 5000. Right. So the usual way to do rejection sampling is I will take the color, I'll use a split vector 4D, so here it's a grayscale texture, so I can take pretty much whichever RGB I want. Here I'll take the first channel, which will be R, and I will say if this color is lower than some threshold, so let's say lower than 0.5, then I'll wire this into a self.kill. So now as soon as I do that, you'll see that I only have particles on the parts of the texture which are brighter than 0.5. However, all the particles are still spawned, they're just instantly killed at spawn time. So this can be pretty wasteful if you have a big area of your texture which is where you don't want particles to spawn on, basically. So that's the pretty straightforward way to do it, what you'd find in other VFX systems. But the spawn on texture node has a density map here. And this is pretty interesting because what it allows you to do is to simply specify the texture that you want to use as a density source, and the brighter the texture will be, the more particles will spawn on those spots. So here if I pick the same texture, now you see that all of a sudden it becomes brighter. I'll just unwire the color. That's because more particles are spawning on the brighter parts. So we'll make these smaller. Right, so you can clearly see here that there are more particles on the brighter parts. So this is the density sampling, and on the P where it's black there are no particles. So you have no waste when using that technique. So you can control a bit more the density if you expose it as a pin and if you wire it an actual texture node. So here I already use the same texture. And here if you uncheck sample row values, this gives you more control about the density sources. So by default it's using the average RGBA, but I can tell it to use the alpha. So here it's a fully opaque texture, so obviously if I pick alpha, they all spawn everywhere. But I can pick red, green and blue, and I can even, when specifying RGBA average, specify custom weights. So these by default are the RGBA weights to preserve the luminance of the texture. Yeah, you can also change the density power. So if I change that, I can change how much particles spawn on the gray areas. Yeah, so this just takes the sampled color basically and applies a power function, and this is the exponent. So let's go to some more interesting things. Instead of this boring logo texture, I am going to pick, so here I'm in the Houdini online package, and I took the man animation texture, which is this texture with lots of animation cycles at different angles from that guy running, which we use in the imposter example effect. So I took that texture and took a vertical slice of it, which looks like that. So only a single angle, the guy is running, and this just gives me a simple sprite sheet animation. So if I use that as the density map, and if I enable the atlas, so here it doesn't do anything, but that's because the atlas is defined in the texture node. So here, I'll reset that to the default. So here atlas source is procedural by default, and here I have atlas subdivisions, so by default it's 1 by 1, so basically no atlas. Here I have 16 vertical images in my animation, so I say 1 by 16, and now I have a single guy there. Let's reduce that size a bit more. So you can see here that the density where this is spawned isn't uniform. This is because by default it's using the RGBA average, and the RGBA channels aren't uniformly distributed. It's a color texture, so obviously it's not all the same color. So here if I take the green channel, it will spawn less on the shirt and hair than on the shoes and hands, for example, which is basically what we see here. Yeah. Instead, if I take the alpha channel, I will have a constant density on this texture, and it will spawn where the texture isn't transparent. So I'm going to do that, pick the alpha, and you can see that now all the particles spawn with the same probability on those texture regions. So I'm quickly going to tweak a few things. I am going to move this a bit further up. 4, 8, 7. Right. And now obviously I'm going to want to animate this. So here on the spawn on texture node, just below the use atlas checkbox, you can see the subrect ID. So when I change that, this is actually the ID of the subrectangle of the sub-UV that I want to use. So I want to animate this value. So to animate this, I will click on this eye icon to expose it as a pin. And one easy thing I can do is just use the curve over time node, just because it gives me nice controls. And I'll wire a curve node, set it to the linear preset, and in the cursor mode, instead of life ratio there, I will simply pick effect age at evolve. So here nothing changes. That's because that value output by the curve is between 0 and 1, and here I want the ID of the subrectangle. So the first one is 0, second one is 1, last one is 15. So I am going to, because there are 16 in total, I'm going to multiply this 0, 1 cursor here by 16. Right, and now I have my particles following the animation as I expect. So in the curve over time node, you have a couple of a couple more controls there. You can see the cursor range and cursor scale. So you can see the scale as a speed. So if I put, let's say, a 10 in there, the animation will go 10 times faster. Whereas the cursor range is the length of the animation in second. So both of these are combined together, and one is basically the inverse of the other. You can tweak either one of these, doesn't really make any difference. It's mostly when you expose them as spins, depends on the value you already have. If you already have the length in seconds of your animation, it will make more sense to expose the range and wire that in directly rather than having to invert it. So here I'm going to say like I want my animation to be 1.5 seconds long, and here we go. So the nice thing with the sample density, instead of the discarding of particles, is that you have frame-to-frame coherency there. If I were to kill the particles, well, I wouldn't be able to have them carry on from one frame to the next. Whereas here, I always have the same number. Like I can literally make this not an infinite even multiplier, just spawn a total particle count of 5,000 and make the particles infinite. I reset and I have those 5,000 particles that will always stay there no matter what, and no killing, no spawning. It's always the same that carry from one frame to the next. And the nice thing with the spawn density is that it keeps a coherence from subrect to subrect when you have an animated sprite sheet like that. So here, if I drop a color node just to illustrate, I'll pick whatever color, and here in the hue variation I will, so I need to reset because now they don't respawn. But so here you can see that those color differences carry on between frames. So you can see the particles slightly moving up and down. That's just because the number of white pixels in the texture vary from frame to frame, so there is some adjustments there. But the density sampling provides you a nice frame-to-frame coherence. So I could even try to lerp between two frames, but you'll see that in the case of this animation, it doesn't exactly give me the expected results. So so here I just copy-paste the two nodes. And here in the point is to lerp between those two positions. So I lerp between the base frame and the next frame. So for the next frame, I will use a seal node. So here, when you wire in a floating point, a rectangle ID, let's say 11.3 or something, the spawn on texture node will always take the floor of that, so it will be the integer part. So 11.3, it will display subrect ID 11. 11.7, subrect ID 11. 12.1, it will take 12, etc. And the seal node does the opposite, so it takes the upper bound. So if this is 11.3, it will give me 12. So that's actually the second rect I want to lerp with. So I will just wire this, into the subrect ID. And to lerp between those two, I want the fractional part, which will be basically the fraction between those two integer numbers. So I can use the frac node there. We'll wire it in here and wire that as the position. And you can see here that it goes completely bonkers. So I'll quickly restore my event multiplier to spawn in particles per second, just because it gives me better feedback in my opinion. Right. So this goes bonkers because the two spawn on texture node are actually each picking a different random UV to start with. So here, if I reduce the update speed of the simulation, you can see that the particles do indeed smoothly lerp between two positions, but the two positions have nothing to do with each other. They are at completely different random locations. So fortunately this is very easy to work around. Here I have the input UV value that I can expose as a pin, so I'll do that for both nodes. And in there I will wire in a random float2, which by default it's basically just a rand node, a preset of a rand node, which will run between 0 and 1 for a 2D vector. And if I wire in the same UVs in there and I reset, now you can see that it behaves much better, and we do have a proper lerp between the different frames. However, you can see at the bottom here that there are some small packets that travel between different regions. This is expected. Actually, it's the way that the density sampling works. It will not allow you to properly lerp between different frames of a non-convex shape. You will always have those kind of artifacts. That's the price to pay to have a proper uniform distribution of the samples. It's just not made to work with lerping between two different frames. Yeah. So if your shapes are convex, you can definitely use that. Otherwise, if you don't like those artifacts, well, you'll have to either increase the number of frames of your animation so that it's not perceivable, or use a different method like sampling an actual skin mesh. Right, so there is one last thing I wanted to talk about. We can see here that at the last frame of the animation, the frame will appear to freeze. I'll actually use that here. Where it will be probably here. Yeah, so here the frame freezes. So that's because at the last frame, the seal node will, when we are at 15 point something, the seal node will return 16, but there are the valid IDs for the subrectangles are only 0 to 15 included. So at the last frame, the seal will be clamped to 15 internally. So we'll be lerping between two frames at 15 and we'll get no lerp, hence the freeze we see there. So to work around this, we actually want to, when this returns 16, we want it to use the subrect ID 0 to lerp back with the original frame. So we can do this very easily. I'll just do a compare. Is it 16? Wire this into an if. If it is 16, I leave this empty, it defaults to 0. Otherwise, I take this actual value and I will wire this back in the subrectangle ID. And we should be able to see now that we have no more freezing, even though the lerp is doing this funny packet transfer thing. And you might think that it's pretty overkill to use a curve here. By the way, we could use effect age and wrap it manually using a fract and another multiply or something. This doesn't actually make any difference. When I build this effect in shipping here, you will see that the curve sampling is completely gone, and this node is actually using effect age, scaling it by our speed, using a frac, and scaling it by our times 16 there. Well, that might not be times 16. Where is that mole? Oh yeah, the mole is here, sorry. Yeah, anyway. So this is because the graph optimizer sees that this curve is a linear curve between 0 and 1, and it just removes the sample of the curve entirely in shipping. If you look at it in the editor mode, which is the default and has a whole bunch of debug stuff for the editor, you will see the actual curve sample there, but this goes away when importing the game engine and the effect is baked. And last but not least, using the spawn on texture node, if I rewire the texture into the diffuse map, then I can just pick the color, wire it in the color of the billboard node, and if I switch that to alpha blend, I have my reconstructed texture with the proper colors. You can also expose in the outputs here, you can expose the normal or local normal there if you want to do some more advanced lighting and things like that. So that's it for this video. Hope you enjoyed it and it was useful, and see you next time.